For this problem, we need to solve for how deep an ultrasound is able to penetrate the skin. From the data we're given, we know that the penetration of tissue is approximately 200 times the wavelength. So to find the depth of penetration, we need to find wavelength. Now, to find wavelength, we need to use a wavelength formula. Unfortunately enough, we are given two components of the equation so that we can find wavelength. First of all, we're given the frequency of the penetration of ultrasound, which is 4.5 megahertz. However, that's in megahertz. For the equation of wavelength, we need it in normal hertz. So given the 4.5 megahertz, we can convert that to hertz as 4,500,000 hertz. With this, we can then implement that into the equation, and we can use our final point that we need to complete the equation, which is that the speed of sound in the human tissue is approximately 1,540 meters per second. Now, once we have these two numbers, we have our frequency and speed of sound. We can then solve for lambda or wavelength as speed of sound over frequency. And as you can see below, we have our 1,540 meters per second over our 4.5 megahertz. We convert it to our hertz, which is 4,500,000 hertz. And once we divide, we get 0.000345. Now that we have that, we can then solve for depth. So now that we know it's 0.00342, we then know our wavelength is this in meters, and we know the depth is approximately 200 times our wavelength. So if we multiply our lambda or wavelength by this 200, or multiply it by 200, we can then find the approximate depth of the ultrasound into the tissue. And once we do this, we multiply, we get 0.0684 meters, which then we know that the depth of the ultrasound into the tissue is 0.0684 meters.